In this video, I'm going to show you how to do a couple of things using Numbers, which is Mac's spreadsheet program. I'm going to show you how to construct graphs and edit those graphs, how to add error bars to your graph, how to add and edit best fit lines, and also how to deal with outliers. Now, I apologize if this video is kind of long and it's condensed. I have shorter tutorials for Microsoft Excel. Personally, I prefer using Microsoft Excel. I find that it has more functions, especially for students. But this video is for my students who don't have Excel and can only work using Numbers. So what I have here is a sample set of data. I have my independent variable, which is the concentration of copper 2 sulfate on the left, and I have my dependent variable, which is voltage, on the right. I've also calculated the average for each set of trials of every data point. So to construct a graph, simply select your independent variable values, press Command, and then select the average values, which is what we're going to plot on our graph. Click on Chart and select the Scatter Plot option. And you get this very basic looking graph. So what can we do with this graph? First of all, I'm going to take this out. There's a couple of things. First, you can change the appearance of those circles. They're supposed to be data points. So if you click on that data series, go to Style, you can edit the size of those points, and you can even choose to have them filled out so they look just like data points, like so. Okay, I don't know why those turned out blue. Let's find out. Probably because it had lines around it. So there you have it, data points instead of data circles. The next thing you probably want to do is add labels to your axes and to your chart itself. So to add a title to your chart, click on Chart and select Title and put in a descriptive title. We can use the format, the effect of concentration of copper sulfate on voltage. Let's add some axes labels as well. So click on Axis. To add a title to your x-axis, click on X and click Axis Name. You can do the same thing for the y-axis. And let's edit those labels to include the quantity, which is concentration of copper sulfate on my x-axis because it's my independent variable measured in moles per liter. And the same thing for my y-axis, including here my uncertainties. Well, there is a nice function with Mac. You can put in the plus minus sign by pressing Option, Shift, and the plus key. Okay, so now we have labels and a title. Notice too here that the increments on my x-axis are kind of strange, so we can edit that as well. Go back to axis and let's fix the x-axis. Here you can play with the major steps. So if I go up, well, that looks better. So increments of 0.1. I can do the same thing for my y-axis. Oops. My y-axis, and let's play with that. No, that doesn't look very good. That looks much better. So that goes in increments of 0.1 as well. All right. Let's also add some grid lines on our graph so that we can gauge the scale. So still within our axis tab and under Y, let's fix our Y grid lines. So it shows major grid lines and you can see them here, but let's put in some minor grid lines as well. Okay, and let's do the same thing for the x-axis. So go back to X, put in some major grid lines, and also put in some minor grid lines. Okay, and to gauge your scale, what you want is, so you see how these are rectangles, you want them to be a little more square-like. And they don't have to be perfect squares, but close enough. Basically, they should look like graphing paper. There we go. So we've constructed and edited our graph to make it look more appealing. Now let's add some error bars to our data points. So I'm going to create a new column called error. Now there are different ways to construct error bars, and if you want a tutorial on that, do check out the Microsoft Excel version where I go through constructing error bars in a lot of detail. But for this particular video, let's just use one of the methods, and I'm going to calculate the difference between the maximum and minimum values and divide that by 2. So I've just opened and closed the parentheses and put in divided by 2. I'm going to click inside that parenthesis and type in maximum. And then I'm going to select the 3 trials that I have for that particular data point because I want numbers to find the maximum within this set of values. Okay, I'm going to close that and then subtract the minimum. So I'm going to type min, click that. And what I can do here is I can really just copy that because it's the same data set that I wanted to find the minimum for. Press enter, and there's our error. And you can copy that formula down. If you want to check and see if standard deviation might be a better way to construct error bars, simply type in stdev, click that, and again select the values for the 3 trials, press enter, and copy that formula over. Now notice that they're fairly similar, so I think I'll just use the first calculations that I did and erase that. Okay, so to add error bars, again, click on your chart, go to series, and our error bars are for voltage. So I want y-axis error bars. I'm going to choose positive and negative. I'm going to ignore everything else and click on custom values because the values for error are different for the different data points. So for the positive value, I'm just going to delete the default and click and drag all my values for error, which tells numbers that the error for this data point is this one, and the error for this data point is this one, so on and so forth, and press enter. I'll do the same thing for the negative error values as well. There we go, and press enter. So there we have error bars, and this will help in your discussion because then you can interpret the data points that are perhaps less reliable than others. And certainly if you have very large error bars, you can talk about the quality of your data and support that. Okay, so we've added error bars. Let's now add a best fit line. Again, click on your chart area and go to series, and you'll see an option here that says trend lines. If you don't see that, you probably just have to click the little arrow that's beside, the little triangle that's beside trend lines. Choose the best one that seems to fit your data, and you can experiment with that a little bit. I think for this one, we're just going to use a linear trend line. If you want to interpret your trend line later on, it also helps to show the equation for that trend line and the R-squared value. The R-squared value is very useful for linear graphs because it's an indication of how appropriate the linear fit is for this set of data points. The maximum R-squared value you would get is 1 for a perfect linear fit, and so this one is pretty good. We have 0.9697. You also probably want to edit the appearance of that line. I don't know why Numbers chooses large, thick things as a default. So if you click on your trend line, it should take you immediately to options, and you can choose the color for that line, and you can also choose to make that a little thinner. All right, so that's the best fit line. We can also construct lines of maximum and minimum slope, which means lines that are the most steep and still hit most, if not all, of our error bars, and a line that's also the least steep. Okay, so maximum slope, let's start with that. Maximum slope. So the steepest line I can draw will connect the lower boundary of the first data point and the upper boundary of the last data point. Lower and upper. So my first data point is the lower boundary, which would be the average minus the error bar. Okay? And the upper boundary would be the average plus the error bar. So the least steep line that I can draw connects the upper boundary of my first data point and the lower boundary of my last data point. Upper and lower. So for the first point, it's going to be the upper boundary. So the average plus the error, and the last data point is going to be the average minus the error. Okay, now it takes 2 points to make a line, which is why we have these 2 points here. Now how do we put that into our graph? So click on your graph and edit data references. All you have to do now is just select the values for the maximum slope and the coordinates for the minimum slope, and they should appear on the graph. Now again, those horrible circles show up, so let's maybe change that. Let's click on the green one, go back to style. So what I clicked on was the top portion of this bar here. I don't really know what that is. And let's remove the line and let's change the color to, I don't know, maybe blue, and change the size to about 4 or 3. Okay, and let's do the same thing for the yellow dots. Let's see, change the size to 4, 3, take away the line, and change the color to maybe red. Okay, great. So now we have these 2 sets of 2 points each, and we just have to create now the line. So click on that again. Click on Edit Data References if you get lost, and click on the series for maximum slope, and that should take you to this window here, and you want to add a trend line. And we'll just use a linear trend because this is a line of maximum minimum slope that you can only use for linear graphs. Okay, and we can edit the appearance of that trend line as well by clicking on Style, and we can color code it, use the same color, blue. Oh no, wait, that's the data series. Okay, we'll edit the best fit lines in a minute. Let's put in a line for the second one as well, for the minimum slope. So I clicked on the top of that column, and let's add a linear trend line. And if you'd like, you could also show the equation for these lines. And you can interpret the slopes later on. So what this tells us is that the slope of our best fit line is 0.6867, but really that slope can fall anywhere in between the values of 0.533 and 0.933. So constructing maximum and minimum slope lines gives us also a range for our slope, and that may mean something if your slope is to signify a particular value or constant. So let's now edit the appearance of these lines. So all you have to do is click on the line itself. There we go. And you know that you've selected the green one because it shows you the points of the green one. And let's change the color of that to, let's say, blue. Let's change the weight of that line as well. You can even make this dotted if you wish. Let's do the same thing for the minimum slope line. So click on the minimum slope line. Let's make that red. You can change the weight and also make it dashed. There you go. So we have three lines here. We have our best fit line, and we have our line of maximum slope and our line of minimum slope. The last thing I wanted to show you is how to deal with outliers in your data. Now, this particular data set doesn't look too bad, but let's say I decide that this data point, the third one, is an outlier because the best fit line barely touches the error bars and the maximum and minimum slope lines don't touch it at all. So how do I remove this data point from my graph so that it doesn't interfere with my best fit line, but at the same time still have it appear as a data point? So basically all you have to do is move that data point into another column. So I'm going to create a new column here called outliers. Okay, and I'm going to move that data point away from the rest of my data points. And watch here as I do this, watch the R-squared value. Right now it's 0.9697. If I remove that third data point, the R-squared value increases to 0.9798, which means that the linear fit is now better for these 4 data points that I have. But I can't remove that data point completely. So I've removed it from this column here, but I'm going to move it to outliers. So let me do that again. So let me take this away. Oops. Let me cut that out and put that in here. And for some reason, Numbers doesn't keep the original formula. Let's see if there's something called paste special, which we have in Excel. Paste and match style. No, that doesn't work. Okay, that's fine. So let's paste that in, but let's make sure that it's calculating the average for the same set of trials. Now, if you have a number of outliers, you really only have to do this once and copy the formula down. So don't worry about having to edit every cell for every outlier. You also want to put in the error for this data point because now it's in its own column. And let's copy this or take it out, paste it in here, and let's fix that formula. So this should be these 3 data points, and I can just copy this here. There we go. Okay, and we'll do the same thing to add new points to our chart. Click on your chart and click on Edit Data References, and now select your Outliers column. And there's your data point. And somehow it doesn't interfere with your R-squared value because it's no longer part of this best fit line. This best fit line was constructed only using these 4 data points. So let's fix that data point as well. Again, change the size, take away the line, and make it the same color as all the other data points. Let's see how that looks. Yep, okay. And let's add the error bars. So Y error bars, positive and negative. Ignore everything and click Custom Values. Delete the default. Select the values for error. Do the same thing for the negative values. And there you have it. This is a graph that you can place into your lab report. So what are the components of this graph? First of all, you have your independent variable on your x-axis, and that's labeled, and you have your dependent variable on your y-axis, and that's labeled. Ooh, I just noticed something. Notice how these increments have gone all wonky. So let's review how to fix that. Let's go to axis. Let's go to y, and let's change the steps. There we go. Okay. So where were we? Yes, axis labels, descriptive title. We have data points with error bars. We've been able to move outliers away from all the other data points so that it's not part of constructing the best fit line, and we get it doesn't interfere with a general trend that the other data points share. We have a best fit line and lines of maximum and minimum slope.